The Federal Airport Corporation proposes to build a third runway to ease congestion at Sydney's busy Mascot Airport. In line with this expansion, Australian Steel Mill Services at Port Kembla on the New South Wales south coast put forward to the FAC a proposal to use blast furnace slag as a sub-base and base material for the project. Slag has proven itself over a number of years as an excellent construction material for major highways and heavy haul roads. However, the reaction of the material to the rigorous airport construction methods needed to be demonstrated. After initial testing by the ASMS laboratory, a demonstration project was carried out at Mascot Airport in March 1992. This involved constructing a car park in the southeast area of the airport. The project was carried out by duplicating the construction methods nominated by the FAC by the accredited airport pavement contractor, Kyprios, and FAC's consulting engineers from Sinclair Knight. Blast furnace slag from Port Kembla was delivered to Mascot Airport and stockpiled on site. It was then loaded into a hopper at a nearby pug mill for mixing with water to a consistency suitable for compaction. The material was placed into the spreader bin of an automatic paving machine, which augured the material to the full width of the machine's capacity. The newly laid sub-base was then compacted by the machine's vibratory box, leaving the slag at a predetermined level using automatic levelling devices. To confirm these levels, manual checking was also carried out. The material was kept watered to maintain the moisture level suitable for rolling. A Stein 1802 roller was then used to give initial compaction prior to proof rolling. For the purpose of the trial, extensive testing was carried out at various stages during the construction. Samples were taken to check if any degradation of the slag occurred. As can be seen, segregation did not take place. The material was also checked for compaction using a nuclear testing device. These tests showed that after initial compaction, the required density had been achieved. Excellent results were also achieved when a similar test was applied to subsequent layers. A second trial was carried out on an access road to the car park by placing a thin 300mm layer directly over loose, uncompacted sand. The slag pavement received 3 passes of a roller similar to the 1802 before being subjected to a macro roller loaded with 50 tons of steel ballast. As well, the tyres were pressurised to 200 kilopascals, giving an equivalent load and tyre pattern to that of a large aircraft tyre on a runway pavement. The purpose of proof rolling was to assure the material's integrity against breakdown and that the material was not plastic under heavy tyre pressure. Testing after rolling proved the material did not gain in plasticity and minimal particle breakdown occurred. The modest material breakdown which did occur increased the 75 micron size particles, but the gradings were still well within the FAC specified requirements. Proof rolling was completed successfully on all slag placed on the first attempt.
We are presently compacting material of a slag nature for ASMS. We are presently putting it down with an ABG paver and compacting it with control equipment from FAC. The compaction equipment that we are designated to use are a 96T roller and also a 50-ton Marco roller. These 2 rollers are supplied by FAC to the contractor for the compaction required here.
What are the results so far?
The results so far are good. They are indicating good compaction, up around the 100% mark at this stage.
It seems clear that the airport pavement built with this recycled material will have excellent properties. Its ease of placing will reduce construction costs and also reduce the time required to complete the pavement section of the project.